So today we're going to be working kind of backwards from what we did last Thursday. We're going to be working from a graph backwards and writing equations. So I got a graph up here. I'm looking for you to write me an equation in factored form. So let's, oops, it went away. Let's talk about this. We've got some x-intercepts here. I'm hopeful that you're looking at the x-intercepts. Is that what you guys are looking at? We got an x-intercept here at -3. At -3. Can anybody tell me what factor we must have in our equation someplace if we got an x-intercept at -3? X plus 3. X plus 3 must be a factor of this because we see an x-intercept at -3. So -3 is a 0. All right. And I'm hearing from a couple of people that the exponent on this would be a 1. Are you certain that it's a 1? It could be a 3 or a 5 or a 7, but it's definitely odd, and we know that because why? Because it's crossing the x-axis there. What do you mean, wouldn't it be a negative? So you're looking at the end behavior here. The end behavior is determined by all of the intercepts together. You can't find an end behavior just by looking at one intercept. And yeah. So what we do know right now, and thank you for that, is what do we know about our lead term based off of the end behavior? The lead term's got to be positive for sure. And what about the power on the lead term? It must be an even power because we've got an end behavior that matches even power with a positive lead term. Okay, let's move on to our second intercept. I've got another intercept here at -1. So tell me about that factor. X plus 1. And that appears to be bouncing off of the x-axis. So what's that mean about the power on x plus 1? It's probably squared. Definitely even, probably squared. And there's one other intercept at +2. Tell me about the factor that we must have because of that intercept. X minus 2. And what's our exponent going to be on that factor? It's going to be, say again? It's odd or even. Tell me that. Odd or even. It's definitely odd because we're crossing the x-axis there. So it's either 1 or 3. I'm going to guess it's probably just 1 because I'm not seeing it kind of do that wiggle as it crosses, that swoop. So I'm going to guess that it's that, and that's the best we can do. Now, the only way I could check it is to graph it and see. And if I saw something that looked different, then I might try maybe changing this 1 to a 3 or this 1 to a 3 or this 2 to a 4 or something like that. Question? I'm not sure. How do you mean by increase?
So like say instead of x plus 1 to the second to the x plus 1.
Okay. Oh yeah. So you're how can you tell? It basically flattens out. If you have the guided notes that we looked at from, we talked about that on Thursday, and that's not super key to what we're doing today, but you asked the question, and I appreciate the question. So I'll show you where it is on the guided notes, and you can have a look back at it. But so like if it's an odd multiplicity root, as the power goes up, and it's always odd, right? It's just going to kind of flatten out near the x-axis. And then the same thing will happen with evens. Instead of it just like swooping down and touching, it's going to swoop down and look like it's kind of almost flattening out near the x-axis. It's really hard to tell though just by looking at it. You can usually tell the difference between a power of 1 and a power of 3. Multiplicity 1 and multiplicity 3 are usually pretty easy to tell. All right, thank you for that question. One more thing. I'm going to tell you for a fact right now, if I were to graph this function, it would not match what's on my graph here, because what could we also have going on in our equation that could change the way the graph looks? And I left a little space here. We could have a factor a constant factor in front that would cause the graph, and someone said, to either be stretched or compressed. And I'm going to tell you that there is one. Can I get you guys to write this equation down if you have not already? And go ahead and put an A in front here. And I want to talk about how to find A algebraically really quickly, and then we're going to practice this a bunch. So in order for me to find A, I'm going to need a value for X and Y. So I'm going to need some other point on the graph other than the points that we've already used. You do not want to use the points 2, 0, for example. If you're curious about Y, you could try plugging in 2, 0 and see what happens to this equation. It becomes pretty useless. What would happen if you plug 2 into this factor? This would become 0. What's that going to make this whole side? Then you're plugging 0 in for Y and you're going to get 0 equals 0. That's not helpful for solving for A. And that's what's going to happen if you plug any other of the x-intercepts in. But the y-intercept could be a useful one for us. So let me tell you what my y-intercept is. I'm going to go second calc value and type in 0. And I'm going to tell you that my y-intercept is negative 1.2. So what I'm giving you right now is the fact that 0, negative 1.2 is a point on my graph. Can I get you guys right now to use that information to solve for A for me? You may need your calculator for this. 0, negative 1.2 is on the graph. So how are we going to solve for A? We're going to plug 1.2 in for Y, and we're going to plug 0 in for all the x's, and that's going to give us an equation that we can solve for A. You're going to need to write this down, but you may need your calculator in the final steps here. So the y value is negative 1.2. And then all of my x's are going to become zeros. How we go? Are you guys able to come up with 0.2? All right. So we could then check by plugging that into the calculator. I'll watch you check by just looking at my answer here, and it was indeed 0.2. All right, so we're going to practice this today. We're going to do a Desmos activity in a moment. I'll put up on the screen. It's going to give you a link, not a link. You can find a link on Canvas, but it's just students.desmos.com. I'll give you a code to get into the activity. If you do not have a computer today, it is your job to find somebody with a laptop that is here that you can share with, okay? So do what you need to do. That's your responsibility today. Find somebody you can sit next to and share with if you don't have your own. Hey, I got to warn you guys about this. There's a couple of things. I made this activity, so it's a little janky. My apologies. I'm not a professional Desmos employee or user. What you're going to find is an image that's on the Desmos screen, and it's going to give you a graph. Now, you got to be careful, especially if you're using a touch screen, not to move that image. If you drag that image off of its location, it's going to screw everything up, okay? So just try to be careful not to move the image. What you're going to actually do is in the left-hand side, underneath, it'll say image, whatever. I want you to click and I want you to write an equation, and I want you to try and get your graph to match the graph that's in the image, okay? So you're going to be creating a graph in Desmos that's going to be over top of an existing graph. And your goal is to make your graph match the one that you see in the picture here. So let me go ahead and get this rolling here.